Hello friends, I am Ranjit Dhunde. Welcome back to the lecture series on the topic Laplace transform. In the last lecture, we have seen applications of Laplace transform, that is how we can solve ordinary differential equation by using Laplace transform method. Again, we will see some more application of Laplace transform, that is how we can solve integral equation by using Laplace transform. Now let us see example 1. Solve f of t minus integral 0 to t f of u times sin t minus u du is equal to t. Now here this f of t be the unknown function and this f of t involves under the sign of integral. So, such type of equations are called the integral equations. Now, for the solution, we recall convolution of two functions, that is f star of g of t is equal to integral 0 to t f of u times g of t minus u du. Now, convolution theorem for Laplace transform. Laplace transform of f star g of t is equal to Laplace transform of this integral. This is equal to Laplace transform of first function f of t times Laplace transform of second function g of t. Here f and g are interchangeable. Now by using the definition of convolution of two functions, this integral be the f of t star sin t is equal to t. Now taking Laplace transform on both sides, we get Laplace transform of f of t minus Laplace transform of f of t star sin t is equal to Laplace transform of t. Now by using the convolution theorem for Laplace transform of f of t star sin t be the Laplace transform of f of t times Laplace transform of sin t. And Laplace transform of t, answer is 1 upon s square. Now Laplace transform of sin t, answer is 1 upon s square plus 1. This is equal to 1 upon s square. Now here Laplace transform of f of t be the common term. Therefore 1 minus 1 upon s square plus 1 times Laplace transform of f of t is equal to 1 upon s square. Now simplification by using cross multiplication, answer is s square plus 1 minus 1 upon s square plus 1 times Laplace transform of f of t is equal to 1 upon s square. Now this 1 minus 1 answer is 0. The here answer is s square upon s square plus 1 times L of f of t is equal to 1 upon s square. Therefore, this Laplace transform of f of t is equal to, now this term in RHS, s square plus 1 upon s square times s square, means s to the power 4. This is equal to s square divided by s to the power 4, answer is 1 upon s square plus 1 upon this s to the power 4. Now applying inverse Laplace transform. Therefore, inverse of this first term, answer is f of t is equal to inverse Laplace transform of 1 upon s square plus inverse Laplace transform of 1 upon s to the power. This is equal to inverse of 1 upon s square, answer is t, plus inverse of 1 upon s to the power 4, answer is t to the power 3 upon 3 factorial. This is equal to t plus t to the power 3 upon 3 factorial means 6. This is the required solution for the given integral equation. Now example 2, solve f prime of t is equal to 1 plus a square integral 0 to t cos a times t minus u times f of u du. F of 0 is equal to 0 be the given condition. Now solution. Now by using the definition of convolution, this f prime of t is equal to 1 plus a square, and this integral be the convolution of cos at star f of t, means convolution of cos and f of t. Now taking Laplace transform on both sides, we obtain Laplace transform of f prime of t is equal to Laplace transform of 1 plus a square Laplace transform of cos at star f of t. Now by using the Laplace transform of derivative, this Laplace transform of f prime of t means s times Laplace transform of f of t minus f of 0 is equal to Laplace transform of 1, answer is 1 upon s plus a square and Laplace transform of cos at star f of t means Laplace transform of convolution theorem. Laplace transform of this cos at times Laplace transform of f of. Now this f of 0 be the 0. Therefore, s times Laplace transform of f of t is equal to this 1 upon s plus a square Laplace transform of cos at s upon s square plus a square Laplace transform. Now simplification, this term in LHS, s times Laplace transform of this f of t, this term here is plus sign minus a square s upon s square plus a square Laplace transform of f is equal to 1. Now here Laplace transform of f of t is the common term. Therefore s minus a square s upon s square plus a square Laplace transform of f of t is equal to 1 upon s. Now cross multiplication, s to the power 3 plus a square s upon s square plus a square times Laplace transform of f of is equal to s. Now this a square s minus a square s be the 0. Here is s to the power 3 upon s square plus times L of f of t is equal to 1. Therefore, this Laplace transform of f of t is equal to s square plus a square upon s to the power 3 times s. This is equal to s square divided by this s to the power 4, answer is 1 upon s square plus This is a square times 1 upon s to the 4. Now applying inverse Laplace transform. Inverse of this first term, answer is f of t is equal to inverse Laplace transform square plus a square by this 3 factorial inverse Laplace transform 3 factorial upon s to the power 4. Therefore, f of t is equal to inverse of 1 upon a square t plus a square divided by 3 factorial and inverse of 3 factorial upon s to the power 4. Answer is t to the power. This is the required solution for the given integral equation. Now example 3, solve f of t is equal to t square plus integral 0 to t f prime of t minus u times e to the power minus u du f of 0 is equal to 0. Now by using the definition of convolution, f of t is equal to t square plus this integral will be the convolution of f prime of t and e to the power minus t. Now taking Laplace transform to both sides, we obtain Laplace transform of f of t is equal to Laplace transform of t square plus Laplace transform of f prime of t star e to the power minus t. Now Laplace transform of t square, answer is 2 factorial upon s to the power 3 plus by using convolution theorem for Laplace transform of f prime of t times Laplace transform of e to the power minus t. Now 2 factorial will be the 2 upon s to the power 3 plus Laplace transform of f prime of t means Laplace transform of derivative. Answer is s times Laplace transform of f of t minus f of 0 times Laplace transform of e to the power minus t. Answer is 1 upon s plus 1. Now here this f of 0 be the 0. Now simplification. Here Laplace transform of f of t be the common term. Remaining terms are 1 minus s upon s plus 1 times Laplace transform is equal to 2 upon s to the power 3. Now cross multiplication, s plus 1 minus s upon s plus 1 times L of f of t is equal to 2 upon s to the power 3. Now this s minus s get cancelled. The answer is 1 upon s plus 1. Laplace transform of f of t equal to 2 upon s to the power 3. So therefore this L of f of t is equal to 2 times s plus 1 upon s to the power 3. This is equal to 2 times s upon s to the power 3, 1 upon s square plus 2 means 2 factorial upon s to the power 3. Now applying L inverse, f of t equal to inverse of this 1 upon s square 2 times t plus inverse of 2 factorial upon s to the power 3. Answer is so this is the required solution for the given integral equation. Hope all of you have understood this topic. Please subscribe this channel and let me know your comment and feedback. Stay healthy, stay safe. Have a nice day. Thank you.